morning, Year 10. I hope you're all well. I'm just going to give you a little bit of feedback on this research methods booklet that I gave to you on Wednesday before we broke up. I'm glad I did give it to you because I didn't realise that I wouldn't get to see you on Thursday. So hopefully you've all had the opportunity to fill it in. If you haven't already, I'd advise you to have a look at it first before watching this video. Have a go at the questions yourself, and then you can kind of self-assess and mark your own work from the feedback that I go through in this video. So I hope this video works. I'm using a brand new laptop that I bought just to do this video, and hopefully if this one works, we'll do some more lessons and get back onto depression after we've done this video. So this one's all about research methods, which we have already introduced. We've done quite a bit on laboratory experiments and different experimental designs. Some of the things that we've only briefly mentioned, like sampling, so a lot of this is independent. Don't worry about it if you have struggled. We've got plenty of time to go through this before year 11. It's actually in paper 2 where you'll be tested on research methods, so we often just use it as part of the evaluation process. But if we just have a look at this scenario, we've got Professor Frink. He's learned that context is important for improving memory. He reads that if you learn something while smelling a distinctive smell, the smell can act as a retrieval cue when asked to recall the information learnt. He decides to conduct an experiment to test this using 2 groups of GCSE history students, 20 participants in each group, and some lavender. All participants have similar grade targets between the grades A star and a B. Okay, so this is based upon real research by 2 psychologists called Godden and Badley. It's often referred to as the scuba diver study. It's not something that we've specifically looked at GCSE. However, if you study at A level, you will have to know about this study. But it's quite common knowledge that people refer to if you learn something in the same context. A lot of students understand that if you, for instance, chew chewing gum, when learning something, if you are asked to recall and you're chewing the same type of chewing gum, then that can aid your ability to recall that information. And there is some truth in that. However, it's not as simple as just giving you the excuse to eat chewing gum in every single lesson. But we have this scenario, and what we need to do first is we need to have a look at the aim and the hypotheses. So you're asked to identify which one's the aim and which one's the hypotheses. It's always easier to identify the aim first, because if we have a look at the second one, aims are always starting with the keywords to investigate if. If you're ever asked to write an aim, always make sure that you start with those keywords, to investigate if. And in this one we've got learning with the smell of lavender can help improve student performance in a history test if tested under the same context. So therefore we can put aim in that box. This must leave the top one as the hypotheses, and we know it's the hypotheses because we have key elements that make it clear that it's hypotheses. It's a testable statement of intent. Students who are tested under the same context, lavender, as the one that they revise under, will score higher marks on a history test than those who are tested under a different context. So we can see there we don't start with the words to investigate if. It is an experimental hypothesis. It's not a null hypothesis, because a null hypothesis would say that there is no difference whatsoever, and we're clearly saying there is a difference. And if we can see here, they're saying higher marks on the history test, which indicates it's a directional hypothesis. However, you weren't asked to do that. You were just asked to identify which one of those statements was the hypothesis. If we scroll down to number 2, Professor Frink is unsure about what type of experiment he is using. Can you identify the type of experiment and evaluate this type of experiment? Now we need to go back to the scenario, and it's quite a tricky question because if we have a look at the scenario, it doesn't make it explicitly clear where he is conducting the research. Now we know generally with the different types of experiment, the environment in which the research is being conducted is extremely important. There's 3 types of experiment. There's a natural experiment, which means that no variables are being manipulated. It can't be a natural experiment because he's purposefully asking his participants to do something, or he's purposefully manipulating the variable, which is lavender. So there we have the independent variable, and the dependent variable is the student's performance on the history test. So that narrows it down. It can only be a laboratory experiment or a field experiment. Now, because we have GCSE history students, and because they are studying a history test, we can make a logical assumption that this is happening in a school environment, although it doesn't say that. Now, because these are GCSE history students and they are studying a history test, which is natural, GCSE students do quite a lot of history tests, they will do at the end of year 11, it indicates that it's more likely to be a field experiment. Now, if you've said it's a laboratory experiment, we could also argue that that has some validity to the argument because it's such a potentially controlled environment. If Professor Frink, for instance, can really control whether or not the students can talk to each other, whether or not there are any extraneous variables that could impact on the students' performance, then it could be a laboratory experiment. However, because it's history students and they're learning a history test, I think we'd have to go with the answer being a field experiment. Now, you're also asked to evaluate the field experiment. We always want to try and make sure that we're referring to the context of the actual experiment itself. Now, a major advantage of a field experiment in this context is that natural behaviour is being observed and being studied. Because these are history students and they naturally will do a history test at the end of year 11, it makes sense that this is natural behaviour. Any teacher could apply these findings to their classroom, whether it was a history lesson, a psychology lesson, a maths lesson. So therefore we're going to say natural behaviour is being studied, which increases the validity of the findings. However, as with all field experiments, generally do have reduced levels of control compared to an artificial environment, which would be a laboratory study. We don't have a lot of information in the scenario, but we could argue that lower levels of control in comparison to a laboratory study could increase the likelihood that extraneous variables affect the results. In this context, extraneous variables could be how much revision the students are doing away from the classroom. If you have a group of students who are spending a lot of time revising away at home and completing homework tasks, then it doesn't matter how much lavender they smell, they generally will perform better than the other group without the lavender if they don't revise. And because it's a natural setting, a field experiment, we don't have that control. So therefore that would be a significant weakness of a field experiment. Then something that you might be a little more familiar with, the experimental designs. Like I always say, students often get confused with experimental design and the types of experiment. So this time we've got independent groups, we've got matched pairs, and we've got repeat measures. I've given a little description about how Professor Frink is going to use each experimental design, and you're just asked to evaluate. Now the evaluation, you don't have a lot of room to write, so bullet points would be absolutely fine. And the evaluations become very similar for independent groups and matched pairs. So if your boxes for independent group and matched pairs look similar for the strengths and weaknesses, then that is to be expected. Now, a major advantage, a strength of an independent group design in this context is the fact that an independent group's design is much simpler to carry out than matched pairs or repeat measures. The reason it's much simpler is because we just need to randomly allocate the participants into the two different conditions, in this context two different classrooms, one with lavender, one without lavender. They both complete the same history test and then we compare the results. That's far easier than trying to match students up or asking students to complete two history tests. So the major strength of an independent groups design is the fact that it's quicker and easier, really practical. Another major strength of an independent groups design is that there are no order effects. Order effects only occur in repeat measures, so we can say that that's a really key strength of using independent groups design in this context. And we'll talk about order effects a little bit more when we talk about repeat measures. However, a major weakness, if we're randomly allocating 20 students into each condition, then it could just be that 20 of the students who really enjoy history, who are really strong at history, end up in condition 1, and 20 students who don't particularly like history or aren't very confident and strong in history end up in condition 2. So therefore we can't be confident that the results between the two conditions are being caused by the independent variable, which is lavender, and not their preference or ability in history. Now if we go down to matched pairs, We know that matched pairs were matching these participants, and it kind of referred to that in the scenario. It said that the students are all A star to B students. So if we match them up and get the students who are the A grade students to be compared to other A grade students in condition 2, then we are significantly reducing participant variables, which is the major strength of matched pairs. We don't want participant variables to affect our results or potentially affect our results. So if we can reduce them, then that is a significant element of control, which will really increase the validity of the results. We could also have the fact that there are no order effects for matched pairs design, because they only occur in repeat measures, which is another significant strength. However, this task isn't as simple as the independent groups, because we can't just randomly allocate people, we have to match them first, and therefore we can put that as a difficulty or as a weakness. To match participants is quite difficult. You might have an A grade history student and compare them to another A grade history student. However, these are two different people. So one A grade student might really enjoy history, they might really enjoy the topic in history, compared to the other A grade student who just has high grades. So there are lots of different variables within individuals that we can't necessarily match, even though we might be matching them on one variable, which makes it extremely difficult to actually do that. Another major weakness is the fact that we still have these differences, so participant variables are only reduced and they're still present. If we move down to repeat measures, the most significant strength is the fact that there are no participant variables, because each participant is taking part in both conditions and we compare their results from condition 1 to condition 2. Participant variables do not affect the results in any way. However, the big weakness that we've mentioned so far is order effects. If we carry out repeat measures in this scenario, we would need to get two history tests that are similar, so they're on the same topics and they're matched on difficulty, which in the context of something like history would be very, very difficult for us to do that. So order effects can be tackled by counterbalancing, which is this next question. Professor Frink doesn't understand how he could use counterbalancing for repeat measures design. Can you explain how we might do this? Now, for counterbalancing, what we need to do, or what Professor Frink needs to do, is ensure that some of the participants complete condition 1 before condition 2, and the remaining participants complete condition 2 before completing condition 1. Now, if we just go back to our little scenario here where we're saying that we've got to have two history topics that are matched on difficulty to ensure the fairness. Well, naturally, if you are going to do two tests, even if it's within 7 days, you might perform differently on the first test compared to the second test. Most people will probably perform better on the second test because you've already been tested once, and even though they're matched on difficulty in the similar topics, there might be little things that you remember from the first test that help you in the second test and vice versa. It doesn't always help. Sometimes you can get a little bit bored and think, actually, I'm not going to revise and I'm not going to try as hard for that second test as I would have done for the first test because I've already got my results from the first test. So this is why we need to get some of the participants to do test 2 first, followed by test 1, and the rest of them to just do it normally, test 1 or condition 1 and then followed by condition 2. So all we do, we know that we've got 40 participants. We just use random allocation again. So we randomly allocate 20 of the participants into condition 1 first, 20 of the participants into condition 2 first. This is where students often get a little bit confused because both groups will still complete both conditions, and we only compare their results for each participant from condition 1 to condition 2, or if they started in condition 2 to condition 1. We don't use random allocation as we do for independent groups design or matched pairs. We're only interested in how the participants perform within each condition. So we don't compare participant 1 to participant 10. We only compare how did participant 1 do in both of the tests. Was there a significant difference? We'd have to do that for each person. Now, counterbalancing is a really common question. It seems to appear quite a lot in the GCSE exam. So we'll keep practicing that when you return to school, and we'll make sure that everyone's feeling confident with how they counterbalance. Some people did this really well when you did your chocolate tasting experiment. If we go down to question number 4, Professor Frink has chosen to use a matched pairs design. Can you, because both groups of students have similar GCSE history grades, can you explain why he chose to use a matched pairs design instead of independent groups design for this experiment? Well, just to answer that question, we just go back and we just get the information here from the strengths of a matched pair and explain why it would be extremely useful. And the key part is participant variables. We want to reduce participant variables as much as we possibly can. Just be really careful, don't say removed participant variables, because that isn't true. They only reduce them. So there you've got a little description of how to use random allocation, which we have looked at in the past. It's not a question, so I'm just going to skip down to the data analysis. Now we've got quite a lot of scores here, and they can be quite difficult when you have so many scores putting them into the calculator, so you just have to be really careful. If you have a scientific calculator, if you're asked to calculate something like the mean score, it's a little bit easier because you can scroll back and make sure that you've got 20 data sets, and you can see and just double check the number of scores that you've put in. So first of all, we're asked to calculate the mean scores for both groups, and all we do to calculate the mean scores, you just add each individual score together and then you divide by the number of scores. So here's my calculator. I've input each individual participant score. You can just see it on the top, scrolling all the way back, starting with the participant number 1 on 28. So we've got 20 scores in there, and then we just press divide by 20. Now that's given us the average score, the mean score of 29.8. I'm going to minimize that for the time being. Now if we have a look and we do that the same for condition 2, if we add all the scores up, the total should be 497, and then we divide by 20, and that should give us 24.85. Now because we've already got one decimal place over here, we'll round up to one decimal place, or 3 significant figures, and we will say 24.9 is the 2 mean scores. Now already we can see that there is a difference, because the test is out of 40. We have one group on average scoring 29.8 and one group on average scoring 24.9. So we can see already that the results suggest that group 1, the people who have learned history while smelling lavender and then tested under the same context, so lavender smells in the room whilst they're completing the history test, have actually done better on the history test on average than those students who have learned and been tested in different environments or different contexts. However, we're also asked to calculate the range. So for the range, all we do is we get the highest score, which in group 1 is 37. And we take away the lowest score, which is 19. So if we do that, the range is 18. Now always remember, the range is the spread or dispersion of the scores. So we don't necessarily want a large range, because it might indicate that some people have performed significantly better than others. And here we have somebody who's scored 19, which we could potentially say is an anomalous score. However, we have another participant here who's got 22 and 24, so we wouldn't say it is an anomalous score. We're just saying that we have a spread of scores of around 18. Now if we do the same for condition 2, the highest score is 34. The lowest score on this is, where is it? Lowest score is 14. So therefore it gives us a range of 20. Now what we need to do is we need to explain, write a conclusion for Professor Frink's study using the data to support our conclusion. Now we're going to be really careful that we are explicitly clear when referring to these scores, the range and the mean score for both. So if we wrote a conclusion, we might say the results suggest that learning under the same context as being tested increases the accuracy of recall. On average, participants in condition 1 scored 29.8 out of 40 compared to condition 2, who scored on average 24.9 out of 40. So there we've referred to both mean scores, and you've got to make it really explicitly clear that we're referring to both mean scores, although condition 1 have a larger dispersion of scores of 18 compared to condition number 2. Now if we look at the sampling, you've been asked to replicate the study to see if the results are reliable. Before conducting the experiment, you need to collect a sample of Holy Family students. Explain how you will collect a sample using the following methods. Now, first of all, whenever we're conducting sampling, we have to identify our target population. Here we've got the target population, which is Holy Family students. Now, it doesn't give us an explicit year group, so we're just going to imagine that it's going to be Year 10 Holy Family students. Now, if we wanted to carry out a random sample of Holy Family students, and we know we're replicating Professor Frink's research, we need a sample of 40. What we first of all need to do is we need to get a list of all Year 10 students, because that's the list of our target sample, our target population, and we need to figure out some way to get 40 of them. So the easiest way for us to do this would be to put every single student's name onto a piece of paper, place all of the pieces of paper into a hat, shuffle the hat around, and then pick out 40 names individually. And what's a really good exam technique is, if you were describing that process, make sure that you make it clear that we give the bag or the hat of names a shuffle before we pick out each individual person. And once we have our total of 40, those people will be our sample. Now you can do this a lot simpler. If we have a register of Year 10 students, we can place them into a random number generator or a random name generator like we often use in class when asking people questions, and we could keep spinning or ask the computer to select 40 people for us. Random sampling is really quick and simple in comparison to some of the other methods. However, you often get representative samples, sometimes often referred to as a freak sample, and that just means that you could, if we put all of Year 10 into a hat and picked out 40 names, we could pick out 40 boys, which obviously isn't representative of our target population, which means we can't generalize the results. Our opportunity sample, that sounds like what Professor Frink has used in his scenario. Opportunity sample is just the people who were there present at the time of the study. So it might be that we just use 2 history groups from Year 10. As long as there are 40 or 20 students in each class, then we have the sample size of 40. Opportunity samples are probably the easiest method because we don't have to do anything, we just have to wait for the opportunity to use people, but again, they generally produce unrepresentative samples. A volunteer sample is where we ask people to volunteer in our research. So we could place posters up around school asking students if they'd like to take part in the research. We can use web pages, often social media is used nowadays for volunteer samples, asking people. We could send out emails. Again, a very simple method because you don't have to do anything as the researcher. People come to you and say, can I take part in your study? However, generally, it's only certain types of people that want to participate in research. So it might be people who are really interested in history. It might be people who have got an interest in psychology, for instance, and therefore it might be an unrepresentative sample depending on the context of the research. The systematic sample, this is where, similar to random sample, we have to get a list of all participants in our target population. So we have to get all the names of every single Year 10 student, we put them into an alphabetical order, and then what we do, we figure out some system to select our participants. So it could be, I'm going to pick every 10th student, every 10th person. So I start at number 1 and then I go down to maybe the 11th person, and then the 21st person, then the 31st person, etc. until I have a sample of 40. Sorry if you can hear a bit of a strange noise, my dog has just decided to walk into the kitchen because he fancies a drink. So I apologise if it sounds a little bit strange at the moment. The last sample is a stratified sample. A stratified sample is the most complicated one. What we need to do for a stratified sample, we need to work out any subdivisions in our target population. So in our Year 10 group, we know that we have a mixture of girls and boys. And we've already mentioned that Often with random samples and opportunity samples, you could end up with an unrepresentative sample of 40 students. So they could be all boys, or maybe 38 boys and only 2 girls. So a stratified sample, we first calculate the subgroups. So it might be gender. So if I know that 55% of my sample are male and 45% are female, I first of all get all the names of the participants onto a list. I would then place all the boys' names into one hat, all the girls' names into another hat, and then I would pick out the number of boys that are required for my study to meet the calculations that I've made in my target population. So for instance, if I found that I needed 55% boys, I will need to make sure that I pick out 11 boys' names, and if there's 45% girls, I need to pick out 9 girls' names. We still use a random sample, but this time I would need at least 2 hats, all the boys in one hat, all the girls in another hat, so that I can ensure that my total sample size of, oh no, sorry, it's a sample size of 40, wasn't it? I was saying a sample size of 20 then. I can just make sure that my sample represents the subgroups that I've calculated. This is obviously extremely time consuming and difficult to do. If we were trying to apply our results to everybody in a society, so for instance everybody in the world, if we're trying to explain things like depression, which we've been looking at, to actually work out and calculate the subgroups in the target population might be impossible for us to do that. Now there's a stretch and challenge there for you to collect a stratified sample for gender. Obviously we can't go through this in class because everybody's got their own choice of social media, and everyone will have their own friend groups, so therefore I can't give you an answer to this. However, it's well worth you having a go at that. If you haven't done it already, maybe have a look at your Facebook list today and work out how many girls and how many boys you're friends with, and then try and calculate, making sure that you have a sample size of 20 that is representative of your social media groups. Obviously we can't have half a person, so you'd have to round up or round down depending on the actual numbers that you've calculated, but it's probably well worth you doing that because it is a very frequent question that gets asked at GCSE. Now we're moving on to the non-experimental methods. We've talked about some of these methods because we've looked at them previously when psychologists have used questionnaires or observations or interviews, and we've talked about some of the strengths and limitations of using these techniques. If we have a look at questionnaires, the first one, write an example of an open question. On a questionnaire, an open question is any question where you do not limit the participant's response. So as long as you're writing a question and giving the participants space to write an answer, whatever they want to write, then that is a good example of an open questionnaire. In comparison, a closed question is probably more frequently used in questionnaires. This is where you'll limit your participants' responses. So it might be a yes or no answer, or you might give them a tick box. So for instance, how do you travel to school in the morning? If I give the options of bus, car, walking, train, etc., and participants are expected just to tick one of the boxes, that would be an example of a closed question. Can you identify one advantage and one disadvantage of using a questionnaire in research? Make sure you explain why in full sentences. Now, because this just says questionnaire, you could refer to an advantage or a disadvantage of the different types of questions used in a questionnaire, or just questionnaires in general. Generally, the biggest advantage is the practicality of a questionnaire. The fact that you can send a questionnaire out to thousands, if not hundreds of thousands of participants for very cheaply. It doesn't cost you a lot of money, and this can be done very quickly. Computers can analyze all the data for you if you've used closed questions. So for instance, every 10 years the government send out something called the census, which is a type of questionnaire that your parents might fill in, and they can do that to around 40 million people in the country, and they can analyze the results very quickly because the computer does all the work for you. You don't even have to do an old school questionnaire on a piece of paper. You can use websites like SurveyMonkey, which we've used in school frequently in the past, where it calculates the data live on your behalf. So practically, questionnaires are brilliant for researchers, especially when you're a little bit worried about the time and the money that it might cost you to conduct the research. The biggest disadvantage of questionnaires is that we don't know how valid the participants' answers actually are. Now, generally what happens with questionnaires is that you get a very low response rate. Only certain types of people generally fill out questionnaires. In the context of psychological research, if we're sending a questionnaire out to people that we've been studying, so for instance, they've already taken part in our research, that shouldn't really be an issue. However, we don't know how valid the answers are that they're writing down. Because we're not there present, we're not 100% sure as researchers if they've understood the question, or if they are writing information down that we actually understand. So we might misinterpret their answers for an open question. And for some bizarre reason, sometimes on questionnaires, people like to sabotage the questionnaires. So it's a bit like that screw you effect we've talked about in the past. This generally does happen when you're using questionnaires as your sole research method. So if you're sending out lots of questionnaires, you generally do get very bizarre answers back or incompleted questionnaires, which then start to reduce the validity of the results. Now, in comparison, I think most people understand what an interview is. However, you have to understand the difference between structured and unstructured. A key term here is an interview schedule. Now, if you're using a structured questionnaire, that means that you have an interview schedule. That just means the list of questions that you are going to ask in the order that you're going to ask them. That becomes really important to make sure that every single participant is being treated in the same way. They're being asked the same questions in the same order. So usually, if you went for a job interview or an interview at university, they would ask you structured questions on their interview to make sure that everybody's being treated fairly. And unstructured is just where you would have a very skilled interviewer asking the questions based upon the responses from the participant. So if you ever watch talk shows where celebrities are being interviewed, it's usually unstructured interviews that will be used by the talk show host, because they have to be really skilled. They have to listen to what the participants say, and then they'll constantly try and probe for a little more information or ask questions again if they don't get the answers that they were looking for. Now, with an unstructured interview, obviously you might have 20 participants who get asked different questions in different orders. So that is an issue with reliability. However, we generally say that unstructured interviews are significantly higher in validity in comparison to structured interviews, because that way, if we don't understand what the participant has said, or if we want them to expand and explain their answers, we can ask them to do that. Then we come on to this key term that we have used in the past, social desirability bias. Can you explain what it means and why it might be a problem with interviews? Well, social desirability bias just means when participants give answers that they think puts them in the most positive or desirable light. Now, that might be that they're trying to help the researcher, or that they're a little bit embarrassed about their behaviour, so they might change their answer or withhold information so that they appear more socially acceptable. Now, an easy way to think about social desirability bias is, as a teacher, if I asked you, how much work have you done at the weekend, or how much did you focus on your homework, chances are you would be affected by social desirability. You would want to give me an answer that puts you in the best positive light. So you might say, oh, I've done lots, or I've really focused, when actually you haven't. If your friends ask you the same question, have you revised for that test? Again, social desirability bias would be a factor, and even though you might have revised, you might want to save a little bit face in front of your friends and say, no, I haven't revised. No, I'm not that bothered about it. So social desirability is a real problem because it reduces the validity of any findings. And sometimes that's why a questionnaire might be more suitable, because questionnaires aren't affected by social desirability the same, because generally they can be answered anonymously, or you're not filling out the questionnaire in front of the researcher. So it might give somebody a little bit of confidence to answer more openly and honestly, especially about some of the more sensitive subjects that we might study in psychology. So apart from social desirability bias, can you identify one advantage and one disadvantage of using interviewing research? Make sure you explain why in full sentences. We said the major advantages. We could argue that validity is increased because we can ask participants to explain what they meant. We can really start to engage and understand their body language, so whether or not they're holding something back. If they've got a closed posture, an open posture might mean that they are giving honest, open answers. However, in the same context, we don't necessarily know if they are telling us the truth. Validity can be reduced, and we could tie that into social desirability bias. Depending on the type of interview, if we use an unstructured interview, it is generally considered to be low in reliability because we aren't being consistent with how we're asking participants questions. We might ask some participants more questions than other participants. And a major disadvantage of interviews is that they take a lot of time. So researchers might have to employ people to go around interviewing participants if it's a large sample of participants, which could obviously increase the costs and the duration of the research, which would be a weakness for a researcher or a university conducting their studies. We're coming to the end now, so we're just asked to look at observational studies. Can you explain why observational studies are said to have higher ecological validity than other methods of research? Well, we know that observational studies are generally just watching and observing people. We've looked at this for Gunderson's research, where she was looking at how parents use person praise or process praise with their children and how that affects their children's beliefs. And we know that that was conducted in the home. So she set up video cameras in the home to watch the parents and the children interact over a long period of time. Well, if we can watch people in their natural environment, then we can apply those findings from that environment to other environments that that person would find themselves in. So generally we would argue that they have higher ecological validity. Now, we have to be really careful here because observation as a method could be used as part of an experiment, or it could be used as a standalone non-experimental method. So just be really careful when you are reading any scenarios. If it's an experiment, it might use observations. If it's a natural experiment, which we know is not a true experiment, it could also be described as an observational study. So Gunderson didn't actually do anything. She just put the video camera in the house to observe how the parents interact with the children. So therefore it's a natural experiment using observational methods. A key question here is inter-observer reliability. If you have a number of researchers watching the same behaviour and recording it down the same, we've got to make sure that they are being consistent. So if I had 5 observers and I asked them, for instance, to go out onto the playground at lunchtime and ask them to record down the behaviour that they are observing, how can I make sure that all of those observers are looking for the same behaviour and recording behaviour down the same? Well, there's 2 ways that we could improve inter-observer reliability. The first and probably most simple way is to film the behaviour. Once I've filmed the behaviour, I can ask all of the researchers, the entire research team, to watch the recording together, and they could discuss their findings and they could discuss how they are interpreting the behaviour to be consistent. I could train the observers up before conducting the research and say explicitly, this is what you're looking for, this is how you should record it down. Or most commonly, I could use behaviour categories, and this would be where I give the researchers a list of behaviours that I'm explicitly looking for, and they just tick off the behaviours every time they see them. So sometimes this is referred to as event sampling. An example at school might be if I ask the members of staff on duty at lunchtime to record every time they see a student on their mobile phone. They can just tick it off. It's very clear, so it doesn't matter if you're studying in different parts of the schoolyard at different times at lunchtime, you know exactly, I'm going to tick off every time I see a student on the mobile phone. Case studies, I think this is the last question now. Can you explain what is meant by a case study? Well, a case study is just a highly detailed study on one or a very small group of people. So generally this wouldn't be an experiment, this would just be an individual who studied for a long period of time. We look at lots of aspects of their behaviour. We might carry out experiments on them, we might use observational methods, we might interview them, look at their family history to collect a lot of data about one individual or a very small group of people. So remember this man here, Clive Wearing. We looked at this man with no short-term memory. So if you remember, every time his wife left the room and she came back to the room, even if it was just to make a cup of tea, he celebrated because it was like he hadn't seen his wife in a long time. He's a great example of a case study. So researchers have studied Clive for a number of years, for about 30 years I believe it is now. They've done lots of different research, they've studied lots about his brain to understand memory. So he's a great example to use to explain what is meant by a case study. The advantages and disadvantages. Well, the major advantage is that we get a lot of qualitative information, which just means highly detailed. So we'd argue that the information collected during a case study is high in validity. The big disadvantage is that we potentially only have one person. So if we're studying Clive Wearing, we know a lot about memory, which is a great advantage, but we can't necessarily generalize the findings from Clive Wearing to other individuals with similar issues with their memory, because we only have a sample size of one, which is very unrepresentative. We know that Clive Wearing suffered from a head injury. Not everybody would have suffered from the same type of head injury. Not everybody would have suffered from a brain injury in the same place within their brain. So therefore, to generalize the results from Clive Wearing to all people would be potentially low in population validity and a major problem. Oh, sorry, no, correlation studies is the last one. So correlation studies, when a psychologist looks at the relationship between two variables, that is true. An advantage of a correlational study is that research can be completed on naturally occurring variables that might be unethical to artificially recreate, such as the relationship between poverty and ill health. Again, that is true. So if we can't make somebody experience poverty to understand how it affects their ill health, however, we can study it. And once we've studied it, we can potentially do something about it. A disadvantage of using a correlational study is that a true cause and effect cannot be established. We only identify a relationship. Again, that is true. Now, the degrees of correlation, so this is just getting into maths. Here we have a strong positive correlation. You can see all the dots that represent individual participant scores, quite in a nice uniform line. And as one variable increases on the y-axis, and the other variables also increase on the x-axis. Then we have a strong negative, again quite a uniform line. And as the variable increases on the y-axis, it decreases on the x-axis, so it's going down. And then we have what we describe as a very weak negative, a very weak positive, it's going upwards, sorry. You can see that the dots, there is a clear indication that it's increasing, but it's very dispersed. The scores are spread out to a very weak positive. Here we have another negative. However, we describe this as more moderate, because if you compare the weak positive to the negative, you can see that the actual participant scores are more closely aligned. So we'd say that that's a moderate negative. Here we have no correlation whatsoever. We can't indicate if it's going up or if it's going down, so we just classify that as a no correlation. And then here, again, we have another negative, and this time it's more similar to our weak positive, with the scores being quite dispersely spread, so we just describe this one as a weak negative. The final point is a word search, which I'm not going to help you out with, and then you have all of the key terms that hopefully you start to familiarise yourself with. So if there's anything on there that you're unsure about or that I've talked about, have a look here first. If not, check your book chapter, which is on Class Charts. And if you're still getting a little bit stuck and need a little bit of help, your parents should have been provided with an email address for me, which is I think it's socialsciences@holyfamilyschool.uk. So you can just email me if you do get a little bit stuck. I'm going to start producing work for next week, which is we're going to go back to depression. I didn't realise how long school would be closed. I honestly thought it'd be for 2 weeks. I didn't expect it to be this long. So we've got to keep working away, because when you get into year 11, your exams will come round very quickly, and we want to make sure that we don't have any gaps, that we haven't missed anything out from year 10. Okay. So that's it for today. I hope you found that activity pretty useful, and hopefully you haven't got too fed up with listening to my voice for the past 45 minutes. I will see you soon. Look after yourselves.